All right, let's jump right in. Today, in this explainer, we're going to arm ourselves with the transferable math concepts you need to deconstruct and conquer complex, multi-step, real-world problems. Whether you're figuring out a cross-country delivery route, calculating battery charging times, or tracking your phone's data usage, the math is entirely the same. We're going to look at how different mathematical tools, like rate, percentage, and time, all seamlessly connect to solve actual, real-world scenarios. Here's the roadmap for today's explainer. We're going to cover decoding complex math questions, mastering speed and time, percentages and changing values, rates for time and cost, justifying claims with calculations, and finally, real-world assumptions and checks. Okay, Section 1, decoding complex math questions, the anatomy of a multi-step problem. So what actually makes these exam questions so scary? You know the ones I'm talking about. They just look incredibly intimidating, right? And that's because they combine a bunch of familiar ideas into one big, messy scenario. They aren't just politely asking you for a single formula. No, they test multiple concepts all at once. You're extracting data, converting units, finding a percentage, and making a judgment call, literally all at the exact same time. But hey, if we approach it methodically using this checklist, we can tackle any situation. Before you calculate anything, your internal monologue should always be asking, okay, what information do I actually need here, and where exactly can I find it? Breaking a massive problem down into these specific microskills instantly removes the overwhelm. You just take it one bullet point at a time. For example, just finding the data is usually your first test. When you're looking at a triangular distance table, say for a delivery route, ask yourself, which two labels identify the row and the column I need? Wait, am I accidentally reading the wrong pair of places? Look at the table. If you want the distance between Bravo and Delta, you just read across from Bravo and down from Delta to find 22. It's that simple. But listen, don't make the super common mistake of panicking and just grabbing the nearest number. Read across, read down, and find the intersection.
Moving on to Section 2, Mastering Speed and Time, Core Mechanics.
Now, these are your absolute fundamental tools. Speed is just the rate of change of distance over time. When you get a scenario, pause and ask, what's given? Well, distance and speed. Okay, what's required? Time. So the crucial takeaway here is that when a question gives you a set distance and a speed, your go-to move is to use time equals distance divided by speed. For instance, if a train travels 180 kilometers at an average speed of 60 kilometers per hour, you just divide 180 by 60 and boom, you find it takes exactly 3 hours.
Okay, but here is a massive, and I mean absolutely massive, common error warning. Pay attention to this one. If your calculation results in a decimal, like 2.4 hours, you cannot just say that's 2 hours and 40 minutes. No way. When converting decimal hours to minutes, you always multiply the decimal part by 60, not 100. So you take that decimal part, 0.4, multiply it by 60, and you get 24 minutes, which means 2.4 hours is actually 2 hours and 24 minutes. Seriously, keep this rule locked in your mind.
All right, let's jump into Section 3, percentages and changing values, working with parts and wholes. Finding a percentage of a given quantity is actually incredibly straightforward. Just pause for a second and ask yourself, am I finding the percentage of the full amount? Say we've got a 500-liter water tank, but it's only filled to 70%. To figure out the actual volume of water, you simply convert that 70% to a decimal, which, is 0.70, and then multiply it by the whole amount, 500. And there you go. That gives you 350 liters. Simple. And what about when you're dealing with a changing value, like, say, a price going up or a battery draining? That's when we use percentage change. Your internal prompt here should always be, what is the starting value and what is the change? This is absolutely crucial because percentage change must always be measured relative to the original amount. Let's say a price increases from $80 to $100. The increase is $20. You divide that 20 by the original $80, giving you 0.25, which is a 25% increase. Remember, the original value is always your denominator. Next up, Section 4, rates for time and cost, figuring out how long and how much.
Think of a machine filling up a tank. If a pump adds 90 liters every 30 minutes, well, its rate is 3 liters per minute. Pretty logical, right? So if your problem then asks how long it takes to add 270 liters, you literally just take the amount needed, 270, and divide it by your rate of 3 liters per minute. The math does the heavy lifting for you and tells you it's going to take exactly 90 minutes.
And we can totally apply this exact same logic to cost. If a printing service charges 12 cents per page and you need to print 250 pages, you just multiply your units by your rate. 250 times 12 equals 3,000 cents. But wait, be really careful right here. Always check your final units. You definitely don't want to hand in an answer of $3,000 by mistake, right? That'd be a very expensive print job. Make sure you convert those 3,000 cents to $30 for your final answer.
This brilliantly illustrates what happens when we pull all these pieces together. When a multi-step situation asks for total time across different activities, things like traveling and waiting, you absolutely have to organize your work. Drawing a quick table, like this courier journey, ensures you account for every single stage. But here's the catch. Remember to convert all your calculated times to the exact same unit, like minutes, before you add them up. You obviously can't add 1.5 hours to 30 minutes without doing a conversion first.
Which brings us to Section 5, justifying claims with calculations, proving the point.
So you might face a problem where someone claims, say, a delivery will take less than 2 hours and cost under $50. Following this decision flowchart ensures you logically check all parts of that claim. First, you calculate the total time and then check it against the time limit. Next, you calculate the total cost and check it against the cost limit. It's a structured process. Keep in mind, if a claim has two conditions, it's only fully correct if both calculations satisfy the limits. If the cost is under $50 but the time is 3 hours, well, the claim is entirely false.
Finally, Section 6, real-world assumptions and checks when math meets reality.
Look, math problems often have to assume a constant rate just to make the calculation possible. But out in the real world, rates fluctuate all the time. Think about charging your phone. It zips from 0 to 50% incredibly fast, right? But then that last 10% to reach a full charge feels like it takes literally forever. Or think about a water tank that fills up quickly at first, but then slows way down as the internal pressure changes.
So, when you're asked to evaluate an assumption, just ask yourself, what actually happens in reality? If the actual, real-world rate slows down and becomes lower than the assumed constant rate, well, the process is logically going to take longer than your initial math predicted. Being able to explain this exact difference between theory and reality, that's what shows true mastery of the topic.
Okay, here is your final revision checklist. Whenever you face a complex, multi-step problem, just fall back on this structure, take it step by step, double-check your time conversions, ensure your percentages are calculated from the correct original value, organize your data, and write a final sentence that directly and confidently answers the prompt. Follow this, and you're golden. So the ultimate question, are you ready to not just calculate, but to actually justify? Remember, whether you're in an exam or just navigating life, the goal isn't just to blindly find a number. The goal is to use math to confidently justify a conclusion. Math is a powerful tool for making informed decisions. So, next time you face a complex scenario, don't let it intimidate you. Grab a practice problem, put this checklist to the test, and prove exactly why your answer is the right one. Thanks for hanging out with me today, and I'll catch you in the next explainer.